In this tutorial, you will learn how to write equations of lines that are parallel to each other. So let's start off by seeing what you already notice. Take a minute to pause this video and write down some observations that you see about the graph or the equations on the left-hand side. Okay, did you write some observations down? What did you notice about the three lines? The green, the red, and the blue. What did you notice about the three equations? Maybe some of your observations were that you noticed that all three lines are parallel to each other, right? The graphs are parallel. And maybe you made an observation that all three equations written in slope-intercept form have the same slope, right? All of the equations have a 2x in the front. So that means all three of these lines have a slope of 2. By the end of this lesson, you should be able to say that you can write equations for lines that are parallel to a given equation. And in order to do that, you need to know one basic fact. Parallel lines have the same slope, or the same rate of change. In order to create a new equation, you're going to use this point-slope formula that we learned about in our previous lesson. All right, let's get started. The first thing you need to know is that parallel lines have the same slope. If you're talking about equations, that's pretty easy to find, especially if it's written in slope-intercept form. Notice my equations on the left. They both have a slope of 3. And notice my equations on the right. They both have a slope of -2. Now, in order to be parallel, you have to have the same slope, but you can't have the same y-intercept, because if both lines had the same y-intercept, they wouldn't actually be parallel. They'd be overlapping, because they're the exact same line. All right, this might be a good time for you to write down the things that you've learned or already knew so far about parallel lines. Pause the video if you'd like to put these in your notebook. Moving on. If I were to ask you to choose the equation of the line that is parallel to y equals 2x minus 7, would you be able to figure it out? Pause the video and give it a try. All right, let's check your response. Did you remember the rules? You have to have the same slope. And a slope is a coefficient of x. So you're looking for an x term, no matter where it is, that has the same coefficient as your given equation. So that's right, the answer was C. Let's try it again. Pause the video and give this one a go. All right, I tried to trick you here. Even though slope-intercept form can be written as mx plus b, it can also be reversed, b plus mx. So hopefully you found the right answer. Remember, the slope is the coefficient of x. Wherever x goes, the slope goes. All right, let's make sure that we understand what actually has to happen in order for lines to be parallel. So the first thing is, in order for two lines to be parallel, they have to have the same slope. I think we get that already. But what if you didn't have two equations? What do I mean? Well, let's say you had a question like this. Now, I know at first glance you're probably starting to freak out a little bit, but this is pretty basic. AB with a little line over it means segment AB. And that segment is formed by passing through those two coordinate points. And segment CD is formed by passing through two different coordinate points. Now you could certainly get a graph, and you could certainly graph all those points, and you could figure it out by using a drawing. There's nothing wrong with that. But I think you know something else that could solve this a little bit quicker. Maybe your slope formula, right? If you have to have the same slope, then your slope formula will be equal for both separate ordered pairs. So let's take a look at segment AB. So segment AB is made up of the points -2, 3 and 2, 6. Remember, when you use your slope formula, the change in y, right, the difference of the y's is the numerator. So our y term will be 6 minus 3. And our x values in the denominator will be 2 minus a negative 2, right? Don't forget that the formula has a minus sign in it, and sometimes your ordered pairs have a negative sign in them. So let's calculate this here. 6 minus 3 is 3, and 2 minus minus 2 is 2 plus 2, so that's going to give us a 4. All right, so the slope of segment AB is 4. Now let's find the slope of segment CD. We're going to use the same formula, but we're going to use different points. So here are our two ordered pairs, and don't forget, the change in y goes on top. So 3 minus 0, and 3 minus negative 1. 3 minus 0 is 3, and 3 minus a negative 1 is 3 plus 1, which is 4. And these two are indeed the same fraction. So the answer is yes. These two segments are parallel. So all I needed were 2 points, and I could tell if the slopes were equal that the lines would be parallel. Let's try another one. Again, show your work for QR, show your work for ST. So my slope formula for QR will be 6 minus 8, y1 minus y2 minus y1, and x2 minus x1. And that gives me negative 2 over 4, which is negative 1/2. And now for segment ST. Looks like I'm going to have 5 minus 2 over 4 minus negative 1, and that gives me 3 over 5. These two fractions are not the same, so the answer is no, they're not parallel. All right, you kind of getting the hang of this? I think it's time for you to try 2 on your own. Pause the video now and give them a go. All right, let's see how you did. The first one was no, the second one was yes. All right, let's expand our understanding now of parallel equations, right? So what if we wanted to create the equation of a line that is perfectly parallel to another? Like, what would the new equation need to have in order to prove that it is actually perfectly parallel? Well, what do we know about two parallel lines? That's right, they have the same slope. So if the equations were to be parallel, then the equations would also have to have the same slope. So what if I asked you this? Do you think you could come up with your own slope-intercept form equation that is parallel to y equals 2x minus 4? Give it a try. Now, did you come up with something simple? Right? Same slope, different y-intercept. So the constant has to be different. How about this one? That's also parallel. How about this one? Yeah, it's not a very friendly number, but that's definitely parallel. So remember, always the same slope. Now, what if I said I wanted a very specific line? Right? Not only do I just want it to be parallel, but maybe I want it to be a certain distance apart, or maybe I want it passing through a very specific point, right? If I wanted a very specific equation line, I'd have to provide you with a bit more information in order to help you create the correct equation. So let's take a look at an example of what something like that might look like. Write the equation of a line in slope-intercept form that passes through the point negative 3, 5 and is parallel to the equation y equals 2x minus 4. So now I can't just willy-nilly make up any constant that I want. It certainly would be parallel, but that doesn't mean it's going to pass through the point negative 3, 5. So if I wanted this particular equation to pass through this point and have that slope, you know what I could use? That's right, the point-slope formula. You should remember this from our previous lesson. Now hopefully you remember that in order to use the point-slope formula, you can insert 3 specific values, and you can rearrange it to be in slope-intercept form. So the 3 specific values that you need are the slope and a point. Now remember, a point has 2 coordinates, so that's where I get my 3 separate pieces here. Again, every time you start, your skeleton always looks the same. So your skeleton starts with your y, your minus sign, your equals, and your quantity with the parentheses on the right. So why don't we fill in our values by using what's in our sentence here? You notice what I boxed off? The point and the slope. So don't forget your point is in x1, y1 order. That doesn't necessarily mean that the first number goes here and the second number goes there. That's not what that means, right? So read your formula carefully. x1 goes here. So that's where my -3 is going to go. And y1 goes here. And the slope goes there. So I've now created an equation of a line that I know is parallel, but it's not in the format that the question asked. It asked it to be in slope-intercept form. So I'm going to manipulate this a little bit here. Y minus 5 equals 2x, and don't forget, 2 negatives make a positive, so that's going to distribute to a +3, and that makes 6. I'm going to add 5 to both sides, and that leaves me with y equals 2x plus 11. So I know it's parallel, but now I specifically know that not only is it parallel, but it's going to pass through the point -3, 5. All right, I'm going to pose the same question to you, but I'm going to format it a little bit differently. So here's a task where you're asked to write an equation in slope-intercept form for a line that passes through a given point and is parallel to the given equation. So there's a drawing here. So number 1 is exactly like the question I just asked you. Give me the equation of a line that passes through x minus 8, but also passes through, give me the equation of a line that is parallel to y equals x minus 8, but passes through the point 5, 1. So this one's pretty simple because I have a point and I have a slope, even though it's kind of invisible, right? The slope is 1. So I could use my point-slope formula just like I did in my previous example. But what about this one over here? That looks a little different. So I have my point, but what's the slope? Right? That equation is actually in standard form, and you can't find a slope by inspection, right? That means using your eyeballs. You can't find a slope using your eyeballs if it's not in slope-intercept form. So it looks like we may need to do some manipulating over here before we can even start our problem. So you know what I'm going to do? I'm going to remove these graphs, but I'm going to keep the important information, the coordinate of the point and the equation. But I'm just going to take away the pictures for now. All right, let's give this first one a go. If I want a line that's parallel to y equals x minus 8, but passes through the point 5, 1, I'm simply going to use my my point slope form, and I am going to fill in all of the correct values. So y1 is 1, the slope is also 1, remember you can't see it, but it's there, and x1 is 5. So when I manipulate this, and I use my addition property of equality here, cross off my additive inverses, and there you have it. The line that is parallel to x minus 8 but passes through 5, 1 is y equals x minus 4. All right, now let's do the harder question. So I've got my point, but I don't have my slope. So it looks like I'm going to rearrange this problem over here. So that's going to give me -3y equals -4x minus 12, clear my coefficient here. And now watch my signs very carefully. See what happened there? -4 divided by -3 is +4/3, and -12 divided by -3 is +4. So here's my equation of a line that I already have. So that means my next equation has to have the same slope. Remember that? Has to have the same slope. I don't know what's going to be over here, but I do know what's going to be there. So my equation is y equals 4/3 x plus 4. Y equals 4/3 x plus 4. So here's what I'm going to do. I'm going to take this part, I'm going to erase this for now, and let's see if I can't just shrink this down. Whoops. Let's see if I can't just shrink this down a little bit so we can fit all of our work in here nice and neat. All right. Okay. So my equation is y equals 4/3 x plus 4. My point is this. My slope is 4/3. And now I'm ready to begin. I'm going to use my point slope formula. Don't forget, you always start with the same skeleton. Fill in my values. Fill in my fraction here. Now, at first I was nervous when I saw that slope was a fraction, but it's actually not so bad. I'm going to tweak this over here because 2 negatives make a positive, and now I'm ready to distribute. 4/3 times x, and 4/3 times 3 is actually very, very convenient. So I'm going to add 3 to both sides, and now we're done. That wasn't so bad. All right, pause the video, rewind it if you need to go back and listen again to how this problem was manipulated to create that solution. But I think you're ready to try these two on your own. Okay, good luck. All right, let's see how you did. Check your equations. And hopefully you got them right. Well, that concludes our first lesson on writing equations for lines that are parallel to a given equation.